Hello everyone, today we're going to be talking about evaluating trig functions at general angles. So for a lot of these we can still technically draw a right triangle for ourselves just as a reference point, or if we kind of forget, oh, what was I supposed to do with this? But we can always use these ratios to get us to where we need to go. So let's take a look at where these ratios kind of came from. So say, let's look at this blue triangle and say my theta is right here. So it's this whole angle right here. Our angles, which we'll talk about, are always going to be formed with the x-axis. We're going to see that a lot in this chapter. So say I was going to be looking at the sine of this overall angle. I'd be talking about my opposite, which would be this y coordinate here. Opposite over hypotenuse, which is, in this case, would be like my radius if I was talking about at the point 1/2 and root 3 over 2. They don't have to be weird points like, have a root 3 over 2 or a root 2 over 2 in them, but these are three special points that we're going to be looking at a lot in this chapter. Cosine would be very similar. So if I was looking at, this general angle again, cosine would be adjacent, so this x value over my hypotenuse, r. Tangent, TOA, opposite over adjacent, so my y value over my x value. And that's kind of where these come from. And then obviously our, cosecant, we flip it, secant, flip it, cotangent, flip it. So let's take a look at evaluating the trig functions at the point -12, 5. So if I wish, I can draw that right triangle for myself. Just make sure that you draw it with the x-axis. In general, whenever we're drawing a triangle, we're kind of doing it in a bow tie-like formation. So it's got to be with the x-axis. If you're in the second quadrant, we're kind of up here, third quadrant, fourth quadrant, and then first quadrant. So I have, this is my x value, that is -12. This is my height, my y value, 5. Now with real triangles, we would never say that a length was -12, but because we're talking about in the coordinate plane, we're considering that length -12. And then we need to find r. In order to find r, we are going to use the Pythagorean theorem. Or, because this section is going to be a lot of no calculator, in fact, you'll be assessed on it entirely no calculator, I will try to use a lot of those Pythagorean triples that I was telling you about, but you can always do Pythagorean theorem anyway. The numbers will work out nicely for your purposes. So 5 squared plus -12 squared equals, well, we can call it our radius squared, or c squared. So we have 25 plus 144 equals my radius squared. When I add these up, I have 169. And the square root of 169 is 13. Or it's a 5, 12, 13 triangle. Knowing those triples will be very helpful. So, for my sine, so I've got 13 here. For my sine, that's my opposite over my hypotenuse, or my y over my radius. So I've got 5 over 13. Cosecant, I just flip it. Cosine, adjacent over hypotenuse, or that x value over my radius. So -12 over 13. Secant, just flip it. Doesn't matter where you put your negative, so long as there's only one of them. And then for tangent, we have our opposite over adjacent, or our y value over our x value. So 5 over -12, and then just flip it. So it's going to be kind of a process with these. Like I said, you can draw the triangle for reference. However, your ratios, in terms of y, x, and r, will always work out. Now we do have points in our plane that end up lying on what we call quadrant. So these are the quadrant lines, and we call them quadrantal angles. So we have 4 of them. They can lie here, 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 or here, since there's, the positive, negative, x, and y. So on these, I can't draw a triangle because our triangle has to be with the x-axis, and how am I supposed to draw a triangle with the x-axis, having my angle, be right there? So we're just using those ratios with the x, y, and the r to find out for these. Same process with finding our radius. So, even though I can't draw a triangle, it's still kind of like 0 squared plus negative 2 squared equals my radius squared. So in general for your radius, it's going to be x squared plus y squared equals r squared. So 0 squared is 0, negative 2 squared is 4, so that means 4 is r squared, and r is just that 2. We're not looking at any sort of negative radii, since a radius of a circle can't be negative. So we have our little ratios for us here. So sine is our y value over our radius value. So if I have negative 2 over 2, well, I can simplify that just to negative 1. If I flip negative 1, say I had, negative 1 over 1 and then change to 1 over negative 1, that's really still the same thing. So if I flip negative 1, still have negative 1. For cosine of theta, we have our x value over our radius. So x value is 0, radius is 2. 0 over 2, 0 over any number is just 0. For my secant, I'm going to flip my fraction. So 2 over 0 is undefined. So for our quadrantals, because either your x value or your y value is going to be 0, you are going to have some sort of pairing with 0 and undefined. So don't be thrown off by that. And then for tangent, we need our y value over our x value, which in our triangle would be opposite over adjacent. So y value over x value. Here we have another undefined. Can't divide by 0. If I flip this fraction, then I just have 0. So in this case, 4 out of my 6 ended up just being 0 or undefined, and they do come in pairs. If something is 0 on one side, it's going to be undefined on the other. And then the 1 out of this, well, the 2 out of the 6 that isn't 0 or undefined, it's going to be based off of your non-zero x or y value, as well as your radius. So that's it for now. We'll take a look at this more in class, and I'll see you then.